Well, hello there, and we are live. Let me just check. Hello. And we are live. Let's go. Okay. Let's see what can we solve here. Oh man, I just don't want to solve these. Linked list cycle. Reorder list. Remove nth node from end of list. One of the beautiful ones was LRU cache. I recall this is about implementing the LRU cache. So LRU stands for least recently used, and we are supposed to delete that much, right? So design a data structure that follows the constraints of LRU cache. Implement LRU cache. Initialize with positive size capacity. Return the value of the key if the key exists. Otherwise, return -1. Void put into this. Update the value of the key if it exists. Otherwise, add key value pair to the cache. If the number of cache exceeds capacity from this operation, evict the least recently used key. Yep. If I recall correctly, the way I implemented it last time was basically just a hash table along with linked list. So the way you can handle collision, you can just add a list for every hash instead of having a linked list for every hash instead of having a key value pair. Let me just recall. I did it in 2025 to keep track of least recently and most recently. Design a doubly linked list that has 2 dummy nodes. Okay, never mind. Now why because we've been setting, deleting, swapping in middle of the list. This can't be done. Okay, I thought it was the other one. Okay, never mind. There was one of them. I don't recall where exactly. Jeez. I don't know why do I have such an accent, but I have it. Let's check this one out. Okay, we have successfully wasted 5 minutes in figuring out which one to solve. You are the given head of singly linked list. The list can be represented as L0 to Ln. Reorder the list to be in the following form. Yes, this one really made me scratch my head and pull my hairs out actually. You may not modify the values in list nodes, only nodes themselves may be changed. So you cannot basically override the values. You can change the pointers. The node looks like this. There is a value, there is a next pointer, there is an empty constructor. Send the value, it's and there is a parameterized to set the value. And there is another parameterized one where it can take in the next node as well in the linked list. Okay. Suppose head is 1 to 34, and then you are supposed to keep the head as is, but flip the rest of the. Oh, not the rest of the, sorry. Yeah, it is actually L0, Ln, L1, Ln minus 1, L2, Ln minus 2. Yep. It's actually not just reversing the linked list, it's actually alternating it. So 1 would be here, 2 would be here. So basically, odd numbers at odd positions, 1 3 5 7, not odd numbers, the odd nodes at odd positions and even nodes at even positions. So 1 2, no, sorry, alternatively you would want yeah, L0 then L1. Okay. Alternate positions, you would want the sequence to be going forward, and every other alternate position you want the sequence to be going backwards. That is the tricky part here. Number of nodes in the list is in the range 10 to the power 4. 10 to the power 4, that is crazy. That means you can't brute force this one, and the values are just still 1000. Acceptance rate is 65%. What, 1.5 million? That's good actually. So this has to be not that difficult. Okay, let me think. Let's just draw. Let's draw the scenario. Okay. Yeah. Excuse me. I think this must be enough. Yeah, so this is L0. Low. L1, L2, L3. Okay. So what do you actually want to do is take the pointer of the first one, okay, and join it over here. Okay, L0 to it is I think L0 then LN you want, right? Oh my god, not this way, not alternatively. Okay, so you want to take this pointer. Oops. Want to take this pointer. Okay, map it to this one. The nth one does not have it, but you want to take and map it to this one. Okay. Then L1, then Ln minus 1. That is this one only. This is correct. And then what about this one? Is it that's L what? Ln, right? No, you don't keep this one. So L0 to Ln, L1 to Ln minus 1, and Ln to L1, right? L0 to Ln, L1 to Ln minus 1. So by this logic, if I just put in the numbers here, it was 1, 2, 3, 4. Okay, but now the sequence, if you write it, it is 1, 4, 2, 3, right? Is it the correct answer? Order 1, 4, 2, 3. Okay. One way to think about it is that we are just splitting the list. Okay, use some another color. We are splitting the list in equal halves. I don't know what to do with odd number of halves, odd number of nodes, but for even case, you split it in equal halves and then you flip the second one, right? Because yeah, and then insert from first to second. That looks interesting. So suppose it is 1, 2, 3, 4, 5 odd, and then you would be like 1, 5, 2, 4, 3, 1, 5, 2, 4, 3. Okay, why don't we use a 2-pointer here? Like we have one at the very start, one at the very end. You take from the start, you join it to the end. Okay, but then you lost this one. Okay, you need to copy this one as a next, start dot next. Okay. Then you start to end, you join, end to start dot next, you join, and then again you do the same thing. You have end dot previous and you apply the same logic here. That's worst case of O of n, which should work, right? Yep, 2 pointers. There we go. We can also use a recursion because it is a recursive process, but sure, you can use 2 pointers here. So let's just jot this down. So 2 pointers. No, 2 pointers. 2 pointers actually 4. Start at the start, end at the end of the list. You take one from start side, take one from end side. Keep repeating till start is less than end. This somehow makes sense to me. Okay. List. Or do we have a star like this here? I doubt we do that because the reference is directly a reference. Start equal to head. This node. No, we might need. Yeah, we might need end. While we might also need a temp actually to traverse. List node temp equals start while temp dot next. It's actually next. While temp dot next does not equal to null. Why did I type while twice? Temp dot next does not equal to null. temp equals temp dot next. Okay, that means we'll reach to the end. So list node of end equal to, we have one at the start, one at the end. Yeah, what do we need to do repetitively, recursively, iteratively? Is, as I said, add one from the, take one from the start, take one from the end, take one from the start plus one, take one from the end minus one, and so on and so forth till they are equal, or this shouldn't happen. Start is greater than end. That should not happen. Okay. And what are we supposed to return? Are we supposed to modify this in place? You may not modify values. Only nodes themselves may be changed. So you cannot create a new node. You are supposed to do this in place. Okay. So we already have the head. I don't think so you need to define a start. So let's make this head. So what I'll just write this out. This should repeat. Yeah. We'll figure out the strategy how it should repeat, whether iteratively or recursively. Yeah. Head list node hold temp equal to head dot next. Okay, list node m2 equal to end dot previous. Where is the previous one? This is a singly linked list. Oh my god, you don't have a previous one. And we are cooked. Chat, we are so cooked. It is not a doubly linked list, it is a singly linked list, so you can't just do previous. Oh my god. You can't go previous like this. Okay, we failed. We should move on, I think. What else can you try here? As I said, my initial thought was divide this. Okay. And divide in what? I take around from this half, take another from this half. But then the question is, how do we achieve a backwards link? Because it does not exist. Can we utilize the stack here? Okay, let me restore the state of this thing again. Actually, you can just paste it places, right? Okay, that is one of the cool features they somehow managed to pull off. Yeah, let's get the pencil now. Because that's where the entire life started.
Every square computers now have primary control of critical vehicle functions.
all steps to that.